Assalamualaikum and very good afternoon. So today is the last topic on our technical drawing. Okay, this is also the last topic for this class as well, which is called the detailed drawing and assembly drawing. So the purpose of this class is to understand the use of detailed drawing using assembly drawing, convey this assembly drawing into a set of readable or usable data for others to understand. And such important data includes the detailed drawing, the bill of materials, and the balloon annotation. So without further ado, let me just explain to you what the definition of working drawing. So basically, the working drawing is like a set of that you have been doing, but in a working drawing you require two things. The first one is the detailed drawing, and the second one is called the assembly drawing. Assembly drawing is a one file with multiple files of parts. For example, you draw 3 parts, you combine into one assembly drawing. And inside this assembly drawing, you want to purposely show the detail of this assembly drawing that includes the detail of this drawing. So the detailed drawing is basically a multi-view representation of a single part with the dimensions and notes. So you want to measure, for example, you want to use a microscope, okay, to see a part where you want to focus. So that is the detail of the drawing of an assembly drawing. Whereas the assembly drawing is a drawing of various parts of machine or structures assembled in their relative working position. So you have in an assembly parts, you have one called the exploded view, the other one is called the assembly view. So detailed view usually conveys the information and the instruction for manufacturing part. For example, you want to look at the screws of a part. You want to know what is the detail of the screws, for example. So that we use the detailed drawing. The second one is the assembly drawing usually conveys a completed shape of the product. For example, you have combined all the parts into one product. Second one, the overall dimension of the product and relative position of each type, where each of these types are basically joined together, where they should be joined together, and the function of each relationship of the parts together with the components. So in general, we have already discussed about, or we have already done a lot of assignments related to title block, which is very important. So some of you ask me, do you require title block for your assignments? Of course we require. It is a general important information. But aside from that, it's also the part information that we require is also the shape description, the size description, which is the object of the view, and the specification, which is the notes. So you have already understood what notes, for example, the geometric dimensioning and tolerance notes, as well as also the specification of the parts, where the datum is, the hidden lines are, and so on, is on the object view. The notes view are mostly on the information that cannot be conveyed in the drawing. So general information for a title block, for example, the name of the company, the title of the drawing, usually your name, the drawing sheet number, the name of the drafter, the title of the drawing, usually the name of the product, the name of the drafter is basically you, the checker is possibly someone who has the authorization. For example, if you want as a lecturer to authorize your drawing, you put my name, the relevant dates for this action to be taken out, to drawn by, who is checked by, who approved the drawing, and so on and so forth. The revision table, and the most important part that we haven't included is the unit. We should include the unit, which is either in millimeters, the scale, and the method of projection. So all of this has been discussed in your title block. Now we focus on the orthographic drawing, as well as its dimension and its tolerance. Tolerance are based on geometric dimensioning and tolerance, and the specification of its parts, number, names required, the type of material that the part is using. We have not discussed this yet. This will be discussed later on when you are going to do the second part of your technical engineering drawing, computer-aided design. So the heat treatment, surface finish, and general tolerance will be also discussed in the next class. So let's look at an example of an interpretation of a detailed drawing. So look at this. This is a cover plate. Okay, a cover plate usually used in the manufacturing assemblies, where you have mostly a lot of equipments that requires a plate that rotates on it. For example, a material that is put, let's say some tools you want to include inside, you have a metal plate to use it. So a metal plate, first of all, the orthographic drawing. So the orthographic drawing is not complete. It only shows you the front and the side view. However, you should have included the top view. The dimensioning and tolerance, you have this one, you have already found, okay, the datum, the tolerance of concentricity, as well as the tolerance, where the tolerance are, and so on and so forth. This is also the dimensioning tolerance, where you can discuss. The surface finishing is also included in this tolerance as well, and this is known as the title block. Now the general note that you can be specified is, for example, this is the general note that can be used, and the tables, some of the general tolerance of the tables, projection, which is, this is either first angle or third angle, and this is all the required detailed drawing of your drawing. So we move on to the assembly drawing. The assembly drawing has three things included. The first one is the exploded assembly drawings. Once you have combined all the parts together, to draw in a more understood way is when you explode, when you separate the combining parts and display it in an exploded view. For example, a separately displayed, but they are actually aligned in a certain direction according to the assembly position and sequence. So for example, a screws, you put a screws, first you include the screws, and then you include a nut, you include a part, and then you include a nut at the back. So if you take that out, first of all you have to take out the screws, and then you take out the nut, and that leaves the parts in the middle. So that is called an exploded view. A general assembly drawing, all parts drawn in their working position. So basically you have to draw it in an aligned position. And the detailed assembly drawing is when all parts are drawn in their working position with a complete dimension. So this is a detailed drawing means. So for example, an exploded view of a desk. This is a pictorial desk. Okay, a pictorial desk is basically an orthographic view or an isometric view. And you have all the alignments of the screws to the desk. For example, this is the foot of the desk. This is the holder of the desk. This is the screws that attach to the desk holder. This is the desk, the tabletop of the desk, and then the leg is actually attached to the joint, the pivot rail, as well as the wooden screws is attached to the desk. So this is an example of your drawing table, for example. So when you combine all of this, you have to explode this into an assembly view, or you can either an exploded view, or you can explain it in a assembly view. So these are the two explanation of an assembly and exploded view. For an example, this is an example of an assembly view. So in this assembly view, what you can find is you have two things that's required. The first one is the bill of material. The bill of material is a representation of all the parts drawn from 1 to 14, for example, all the information of, for example, number 1, tailstock base, this is number 1. Number 2, the spindle wheels, the center, and so on. Number 8, if you want to look at number 8, the handles, the number 11, for example, fin, hex, jam nut. There are 2 parts there, so 2 parts of fin, hex, jam nut. What else? So this is known as the bill of material. The bill of material can also consist of the cost, of the price of the parts, for example, the length of the size of the parts, for example, and other information, things that you want to include in the bill of material. It is a set of table with all the information parts included in it. And then this is all this round shape is known as the annotation, or called the balloon annotation. So this is used to explain which parts that is at, and it also refers to the bill of material. So these two must be included together. And this is an example of the exploded assemblies, where the assemblies are exploded. And then you have annotation as well as the bill of materials. So this is actually the assembly view, as well as the, not the detail view, but this is the assembly view, as well as the annotation and the bill of material, specifically for you to explain to others what are the importance. If you just presented the assembly view only, you won't be able to explain to other people where the specific parts are joined, for example, where the annotations are, where these informations are. So if you have gone to IKEA, for example, most of the time the drawing consists of annotation and bill of materials for you to read through and to understand. Even for us, even for others who are not a background of engineering, they would be able to understand the requirements of the need for the bill of material as well as the annotation. Okay, so in order for you to draw this assembly drawing, you have to have all the parts and drawn in their operating position, like this one, for example. Okay, this is operating position. Part list or bill of material, known as BOM, you have to have the item numbers. Most of the item numbers start from 1 until the numbers that it only exceeds. A description of the name. So for example, this is the description of the name. The material, so you can put also part number, as well as another column where you have a material for each of these. The quantity required, for example, if you go to this one, you have how many quantities it is. So these are the 4 requirements that you should have in a bill of material. If you don't have the material, you require these 3. These 3 is the most important. The second one is the leader line. Okay, the leader line with balloons around the part numbers, such as this one. The leader line is very important, and also the balloons are important as well. So you need to have a drawing of a leader line, and then a circle just to draw the balloons. So for this course, a title block, you have already understood what title block is. The part list is where you have your bill of material, and the sample parts and the reference of numbers is placed here. Okay, if you're using a A3 size paper, this should be the information you should have in your paper size. Okay, let's look further in the bill of material. So locate above or besides the title block. So it's actually beside. It can either be beside here or above the title block. Fill the table from bottom. Usually they fill from bottom to the top. So like this one, mostly are filled. If you look at this one, it's actually filled from top to bottom. Most of the time, it usually fill from bottom to the top. So depends on which type of standard you are using, either in the international standard or either standard. You can determine whether most of the time they use the name at the bottom, for example the numbers 1, 2, 3 from bottom to the top, part name from 1, 2, 3. It doesn't matter really, but the best is to draw from the bottom to the top. and then this is the number of how many numbers of support, how many supports there are. For example, supports are, there are 2 supports, 1 shaft and 1 screws, and then the material, which is the stainless steel, M3 hex, okay, and then stainless steel socket and cast iron. So you analyze to analyze the steps of assembly drawing. First, you have to analyze the geometry and the dimension of all parts in order to understand the assembly steps and overall machine. And then select the appropriate view. Choose the major parts that have been assembled, and then draw a view of the major parts according to the selected view. And on the 5th one is to add a detailed view of the remaining parts of the working position. Apply this technique relative to the position adjacent to the parts where they needed to qualify. And lastly, you add the balloons, nodes, and the dimension material, and then you create the bill of material. So first of all, if you are given an assembly drawing, draw the dimensions and the geometry first. Once you have drawn it, you choose which parts you want to remove, you want to assemble. Draw the major parts first, and then add the detailed view. After that, you add all the balloons, nodes, and dimensions, and finally you create the bill of material. So that is all for today's class. So I hope you can understand what I am explaining. Although this is, it's COVID time, and it's difficult also for me to present online, as well as for you to understand online, where there is no engagement in class. But hopefully this could help you in your further studies. Okay, although this class is not that difficult, and I hope you enjoy your class, and as well as that you have understood what we are trying to study and understand in this class. So that's all for me. Thank you very much for listening. I hope to see you next time. Hoping to see you in UMP again. Goodbye. Assalamu alaikum.